He took it from my name.
Pick a number.
32.
22?
Why do you guys go big?
Okay, can we just do 2? Can we just do 2? Let's just go 2, 3, 4, 5, 6, 7. And let's just like keep it simple here and go 4, 9, 16, 25, 36, 49. Alright. Quite obvious what that is. Hopefully.
Squares.
Yeah, it's a parabola. Well, now we're going to transform it, and we're going to do so without looking at the graph. We're just going to use the table. So, if I were to do, this thing is dying. F of x plus 3. What happens to, okay, hold on. What happens to the graph? If you remember yesterday, what would happen?
It would just shift 3 up.
Up.
Oh.
It's on the outside. You'll notice, well, I don't know if you'll notice, but anything that just gets multiplied in front of the original, or if it gets added onto the end, that only changes the y values. It doesn't change the x. It either shifts it up or down, or if it makes it wide or skinny, the x values still remain the same, and the y values just get faster, bigger faster. That's what I was trying to say. So like on a table then, if we wanted to transform these points to new points, what would we have to do? What would it look like? Those would stay the same? What would happen to all the y values?
It would up 3. Or
Up 3.
added 3.
7, 12, 19, 28, 39, 52. Easy, right? Okay. What if?
Oh, aren't you missing the square?
Yeah. You know it's squared, but I didn't even
Oh, okay.
put it.
Okay.
This is just like,
I didn't.
it doesn't have to be. This is just, this is f of x, yeah.
Oh, got
It is squared because you're smart and you're like, oh, hey, look it, they're squared. But you don't need to know that. What if I multiply by a number in front, like 3 times f of x?
It goes this way.
The y values, or the x values aren't going to change. But since we know it's a parabola, if this is my regular parabola, what's going to happen?
It's gonna.
Wider?
Well, it's gonna get this way. Where it's just
No.
gonna. It's gonna go thinner.
It's thinner.
Because it
The
goes.
y values get bigger faster. All that happens is these get multiplied by 3. So for your new table, all you'd have to do is 12, 27, 48, 75, 90, 108, 3, 1, 47. I don't know. I'm looking at, yeah. See how these just get bigger faster? That's all the number in front does. They only affect the y values. If we were to graph it, you would just see it just got taller. Okay, but now the stuff inside. What if I do f of x plus 2? Erase everything. If we're thinking about the graph, what happens to the graph?
It goes this way.
Yes, this way.
Plus this.
That's your left, right? Yeah. Okay. You know, okay, here's why. Remember in geometry, what you would use? You're just shaking your head no already. I think that's what.
I don't remember.
Remember doing transformations in geometry? Did you guys
So
do
one.
that?
Oh yeah.
Yeah, where you're like, oh, hey, here's a triangle, and this is A, and this is B, and this is C, and now I'm going to rotate it, and it'll end up like down here. What would I name that point?
C. C or A?
Well, that one would be
Whatever letter it is.
A.
So did you rotate it then?
Yes, I rotated it.
Okay, so A.
A.
And then the next one would be the bottom.
Prime. Thank you. That's what I was going for.
A what?
A prime, and that's B prime,
So-
that's C prime.
And then when you do it again, it's double prime.
When you do it again, it's double prime?
I
Yes.
didn't know that had a name.
It's not I, it's prime.
So
You guys didn't learn that?
he just said like
He just told
told us that one.
He was probably
He put the marks
so
in.
weird.
Yeah, but he didn't give us a
Yeah, he was
name.
probably saying some stupid story or something.
It's on YouTube.
He's like, it goes to 8.
He's one of my subscribers.
Really?
Oh.
No.
Oh, I was gonna be like,
No. Okay.
Can we start the video over?
No, it's not cool. Wait, you. No, too.
Yeah, it's not me.
You saw that?
Me?
Yeah. Yeah. Terrible. Just took a picture of me.
No, I didn't.
Or back there.
Go back there. The door. It wasn't up here.
So here we're going to use the same idea. We're going to call it prime. We're going to have, here's my original, here's my transformation. And this is weird. I don't know.
I wrote on YouTube with this.
The way you do this without a graph is you say, oh, here's my transformation. That's x prime, right? You do that. Your x is going to turn into x prime plus 2. Okay? This is, so then, to figure out what your new x's are, you just solve that equation for x prime. This has an effect on the x's, right? It shifts left and right. Okay. To figure out how it affects it, you write this equation down. You go, oh, my x are going to become x primes plus 2. So now, to figure out what goes in this table, you solve this equation for x prime. Pretty easy, right? Minus 2. So x minus 2 equals x prime. Well, you guys already said that. You're like, hey, it goes left 2. Well, wouldn't that make it go left 2?
No, that makes it right.
So no, look at these. We're going to use, the y values are not going to be affected. We're going to have the same y values. And now, to get my new x values, I use this equation.
So you take
The 0.
You take whatever's over there, and you subtract 2 from it, and that will give you whatever should go over here.
Oh, okay, now it makes sense. Okay.
So, it's going to be 0, 1, 2, 3, 4, 5. And graphically, what would have happened? It just moves it to the left, too. This is important when you start getting crazy ones, where it's like, if you put a number in front of the x inside the parentheses, that doesn't just make it shift left 3 anymore.
It makes it shift 6.
Close, you're thinking kind of the right way. You would have to go, my original is going to equal, I take my x, 2x prime plus 3. You got to subtract 3 and divide by 2.
So it'd be 1.5.
So it would be 1/2 times x minus 3 halves to get your new x values. That's getting crazy. This is like
I like that.
pre-calc level. Ah, it's just a little fraction. Don't be scared. 2 times 1/2 is 1. 1 minus 3 halves is negative 1/2.
Like you just say just some fractions, but like earlier you're doing fractions inside of fractions.
It's okay. Just fractions. Don't be scared. Okay. And we could go through and you can do the rest, but we don't need to right now. We could also use this on a graph. You're about to get ones. You're going to have a graph that's unlike anything you've ever seen. For simplicity, let's do 1, 2, 3. Boom, boom. We'll do a W. How fitting. We can transform that. This is negative 2, 3. This is negative 1, 0. This is 1, 0. This is 2, 3. And this is 0, 2. Okay. And we'll call this, hey, let's be funny. There we go. That's funny, right? Ha 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 ha. What transformation would you like to do to that? Give me one. I want to shift. No, we're not geometrizing. We could do a reflection over the x-axis. How would we do that?
Or we could do it over the y.
Over the.
Oh, yeah.
Over the what?
That's a good one. At least you're thinking. If we go over the x, what would you do to that? To the equation?
It would be.
You would just make a negative. Put a negative in front, right? Okay. Anything that's in front or out here only affects the y values. Anything inside affects the x values. It's important. Let's do this. Let's just go.
I got
What? What do you want to do?
dilate 4.
Dilate. We're not doing that right. That's
Minus. Well, I don't know the other words for it.
I was gonna say just up, down, left, right. You know.
Oh,
I'll just
Big.
No.
Up
Let's
to,
go.
Up to.
2
to
times
right
w
4.
of x minus 4 plus 1.
So it's gonna go
So it's
up
gonna go
one.
up one.
up 1
And it's
to
gonna-
the left.
It's gonna get thinner.
It's gonna go to the right 4.
It's gonna get thinner,
Oh, yeah.
go to right 4, and up 1.
Yeah.
Okay. So here's the easy way to do this. It's not quick, but it's easy. Write down all the points. Here's my old ones, -2, 3, -1, 0, 0, 2, 1, 0, and 2, 3. It would be easy if I didn't have that 2 in front. I don't think you'd have to write down the points, right? You could probably just draw a graph and go right 4, up 1 of everything, and it would work. You would just go, done. But that's going to mess us up, isn't it? So let's actually calculate the new points. So here's my old one, here's my new one. And you do them one at a time. You do x or y first, it doesn't matter. So would you like to calculate the new x's first or the new y's first?
X.
Go for the hard one first?
Oh my God.
What is the only part of that that affects the x values?
-4.
The -4.
Okay? I should have made it harder.
No,
No,
we're barely
no.
learning.
Okay. So, write yourself a little equation. You're saying my old x equals new x, oops, -4, right? So then what do you have to do to get your new x's? Add 4. So you take your old x plus 4, and that'll give you your new x.
So -2 plus 4.
So,
then it's -2 plus 4.
-2 plus 4 is 2. -1 plus 4 is 3, 4, whoa, 5, 6. That's cool. I didn't do that. So those are my new x values. I'm done with that part. Now I told you the only thing that affects the y values is the outside, right?
So 2w plus 1.
Yeah, it's just, this is kind of, I don't know why yet. I actually just learned how to do it this way this year. It's kind of crazy. I even learn new stuff. Back in my days, we would have just, done it. Whatever. So yeah, you just go 2 times whatever your y value is plus 1. There's no solving the equation.
So for the parentheses, you do the opposite? Or not every time?
So
The inside, yes. You do it this way and you solve it, so it's the opposite of whatever's in there. For the y, it's straight up what it is. You just go 2 times whatever plus 1.
So 3 times 2 is 6 plus 1 is 7.
7, 2 times 0 is 0 plus 1 is 1. 2,
4, 5.
5, 1, 7. Let's see if it looks right. 1, 2, 3, 4, 5, 6, 7. I don't know why I went 7. Oh, doesn't matter. Oh, they're all positives. 1, 2, 3, 4, 5. All right. 2, 6, 7. It's not going to be perfect because I'm not using graph paper. But 3, 1, 4, 5, 5, 1, 6, 7.
So it just made it bigger than
It just made it skinnier. If we would use graph paper, you would see that it is skinnier. It's taller, it got stretched because of the 2, and it went right 4, up 1. It worked.
Ew.
Probably should have started there yesterday. I was thinking about that while I was driving here this morning. That's what I do while I'm driving. I'm just like... So now this is not due tomorrow.
Alright.
Well, tomorrow. Oh, here's Disneyland people. This is what we're doing right now. There's a graph, and then there's some transformations. And then on the back, there's some points, and then some transformations to do, kind of like I just did on the board. Tomorrow is, what is tomorrow? Wednesday? Tomorrow, I'm probably not going to make a video. We're just going to be working on this stuff, so.